So there is about how many? Let me tell you. 12 of you. Okay, good. So it'll be a cozy setting, and then we have until 12, right?
Yeah, until 12.
Yeah. So that's good. So since we don't have that many people, we can just chill a bit. Yeah, just feel free to ask me any questions that you want to know about data science, about COVID. Are you able to hear loud and clear, all of you?
Yep, I can hear from my
Okay,
side.
so share my screen. Okay. Yeah, because originally I did my slide was on Mac, so you should be able to see my PDF, right? So today we're going to talk about how to give you a talk on data science and also COVID-19. Yeah. So a bit of my background. Let me see if I can fit the whole page. No, exercise. Uh, okay, this is better. This is Dr. Lau here. I'm a chief data scientist and also founder of Lead. So for those of you who want to enter data science, I got a PhD in AI and machine learning. So my main focus is on studying the text. So natural NLP stands for natural language processing. So we analyze text informations, and this is particularly useful for those of you who are in, let's say, who wants to do work with product reviews, movie reviews, documents, topic modeling, yeah, etc. This all fall under NLP. And also, if you want to work on things like, maybe you can let me know in the chat, what is your which year are you at, and also what are your degree, what's your major, so I can explain things more towards your direction. And so I'm also a researcher in Microsoft E-Research Center. So I work at Microsoft before, and I'm also government advisor for Smart City and Big Data Initiative. So mainly for uh, Johor State and also Selangor State. And I was also MOE expert panelist for university program accreditation. So those Bachelor of Data Science, Master of Data Science program under local universities, right? They have to go through my accreditation or audit before they can offer it to the students like you all. And so let's talk about Corona Tracker. If you have not heard of or have not used Corona Tracker before, right, there's a platform that we use to keep track of the virus, COVID-19 virus. So we have all the data that's related, and this is how it looks like. So in coronavirus, sorry, in COVID tracker, we have this is our main screen, this is our home screen. So we have a top sections that we talk about the number of cases, global number of cases, Malaysian number of cases. We have confirmed, recovered, and deaths, and of course we have verified news. So if you go to a lot of coronavirus tracking website, right, they only show you the number, yeah, basically, and then show you some charts lah. They're all using a similar chart, and this is something different that we have done because my background is in text mining, is in natural language processing. I understand how to use news to enrich the information that you are gathering, and I understand how to collect relevant or verified news that's related to COVID-19. And yeah, if your parents or your uncle aunties, they like to share, I wouldn't tell people that they are sharing fake news, right? I would just tell people that they are sharing unverified news. So that's the thing. And this one which shows the countries affected. So one of the good things that we have done is we provide an API. So all the 195 countries around the world, they can access our database using open data. And so you just need to click into the country page and you can see their details. So so far we have when we have 195 countries, so we cover every country in the world. Basically, we collected the data about them, and it's available in 26 different languages. So these are not my own work. It's all done by a team of volunteers around the world. So it's like a community or volunteer-driven basis, and then we have these are all numbers lah. We by right now we have 18 million of users and almost 100 million views already. Yeah, so it's a pretty interesting project. It's one of the top 3 Corona tracker websites in the world. So these are some of the countries. So number 1 is India, number 2 Malaysia, number 3 Egypt, and then all the way to Turkey. So they use Corona tracker. We have most of our users comes from this country, and they how do I put it in words? I wouldn't say their government rely on us, but okay, put it this way: they are busy fighting with the virus. So most of the countries, they don't really have a data department, right? They don't have a data ministry, so they tap into our resources and use our data to help them to do all sort of plannings lah. Okay, so a bit of the story, behind Corona Tracker. So it all goes back all the way back to 2020, January 25th. So what happened is that was the Chinese New Year that time. So I live in Australia. I travel around, but I most of the time I live in Melbourne, Australia. So last year I came back, and then last year, yeah, well, it has been a while. 2020, I came back, and then I to visit my mom, and then 25th was the reunion dinner night. So a lot of my friends sent me text message. They was like, "Hey, Dr. Lau, have you seen this website? Like which is this one." So they sent me this John Hopkins University's website. I said, "Hey, have you seen this website before?" I said, "No, what is it about?" And they say, "Oh, this is a website that people use it to track Wuhan virus." Back then, we don't even have a proper name, right? We don't have COVID or whatever. We just call it Wuhan virus because it started from Wuhan, China. So I was like, okay, let's take a look at this Wuhan virus, see what it is, and then look at this dashboard. It's basically just a map lah, yeah, with some of the numbers here and there. And then I was like, okay, but it doesn't really tell me what the whole story about the website, sorry, about the virus. And then as a news follower, you need to know how to keep track of the news and then follow up, right? Follow the development of the news. So that's why we decided to, we identified 3 main problems. Number 1, we are unable to drill down for further details, right? Basically, you click on these countries, you don't have other further details, basically just a high level numbers. So this is insufficient if you for somebody who needs to know more about the virus. And then second thing is insufficient data for analysis. So it doesn't provide us sufficient data to analyze the basically historical data lah. If as a data scientist, I'm always hungry. You give me whatever data that you give me, also I can consume. So it doesn't give us enough data for the necessary analysis and even to build a simple model. And number 3, like I mentioned earlier, is we're unable to keep track of the stories. Okay, so these are the 3 major issues. So whenever you guys are building web applications, or you're building a product, right? So always keep in mind that you need to have a uh, you need to have a story to tell. Yeah, you need to have a story to tell, and you need to have a pinpoint for people. So this is basically the what we have identified. Okay, so and then 36 hours later. All right. So I've gathered a group of volunteers, and we decided that, hey, we want to fix those problems, and then we want to build a product. So 36 hours later, this is our first version. Yeah, if you look at the current version that I shared with you just now, right, it looks pretty fancy. Yeah, but original version is just something like this. So I'm sharing a bit on the COVID and then a bit of the data science, a bit of my experience in startup lah. When you're building something, it doesn't need to be perfect, but it needs to be functional. So this can be applied to your university lives as well, right? But of course, when you take your exam, you need to be perfect lah. Your assignment need to be as good as possible. But in real world, when you build a product, it needs to be functional. So we roll out this version, which is what we call a minimum viable product. It's functional, so we let our users test and we monitor and see whether got people want to use or not. If your product is good and people want to use, right, they will give you feedback like, oh, I'm using it, but I got some problems lah. So not to say your product is good, your product is solving their real problems. Then they will tell you and they will give you their feedback. This is the best part of running a startups. So after that, we made a lot of changes, and the rest is history lah. Is the version that you are seeing now. That is our third major version. Okay, so whenever you're doing something, right, whether you're analyzing data, you're building a product, it doesn't matter. You need to really understand what sort of problems that you are solving. So from the COVID-19 standpoint and also from data science product standpoint, right, Corona Tracker, we provide three things that this is unique that other people don't provide. Number one, dashboard. I wouldn't say dashboard is something that is super unique lah. Like there are a lot of other web applications out there. They have dashboard as well, but it is definitely one of the must-have feature because if everybody has it and you don't have it, it seems a bit odd, right? And the second one is open API access. Many people, they don't provide open APIs. They basically just either they give you the dashboard without giving you the data, or they provide the data in the form of CSV file. So it's very hard to consume those data if you need to. And last but not least, unstructured data. Analyzing structured data is simple. It's very matured already. If you have small data sets, you can always use Excel to analyze. Otherwise, you can always use different Python script, R programming to analyze structured data. But analyzing unstructured data is difficult. It's not something that's so straightforward. And yeah, that's where structured data. Later on, I'll tell you how we collect other types of unstructured data as well. But right now, it's just some news articles and etc. Okay. Any questions? If there's any question, just raise your hand. You can. I think you can turn on your mic as well, right? Yeah, yeah. You can ask as well. So it's a small group, so don't worry. Yeah, you can ask. Oh yeah. There's a chat section as well. Okay, all good. Yeah. So this is the dashboard I was telling you. When you click into any of the country, right? So let's say country Russia, country Australia, we have a proper dashboard for every single of them, and it keeps track of all the cases in the country. And also we calculate different metrics, the fatality rate, the recovery rate, etc. So sidetrack a little bit, yeah. If you are thinking about vaccines, right? Right now, our death fatality rate is about 1.6, 1.6, yeah. At peak, it goes up to about 2%, yeah. It's pretty bad. It's pretty bad. We need to get it at least like 0.1%. Okay, it's about 100 times lower before you can go travel. Yeah, so that's under WHO recommendations. So make sure that you encourage you guys won't be in the first batch, right? Even I'm not in the first batch. If you have any elderly, you have any friends and family, yeah, do remind them, advise them to register at My Sejahtera. Okay. And then the next thing is scalability. Open API first. Yeah, open API. You can go to api.coronatracker.com and oh yeah, maybe let me know. Or I'll ask Millennium lah. What are your background? You can just let me know in the chat section.
I guess most of us here are actually from engineering background.
Actuarial.
Engineering.
Engineering. What
Yeah.
engineering?
Based on what I have right now, generally it's most of us here are either E&E, electrical and electronics, robotics and mechatronics, or civil.
Okay. So no one from CS or software, right?
Mm, if there is, do let us know in the chat. Yeah.
Hello. Don't be shy.
Mm, mm, anyone from
Okay. I saw
CS?
Nico
Okay.
is typing. What about the rest? Brian, Zite, not from CS. Yeah lah. What's your background? Kasturi, Darren, Civil. Okay. Have you which year are you in? Third year, okay. E&E third year. So you all should have done okay. So good. So preparing to go to work already, right? You all should have done some programming before, right? C plus plus, maybe Java. Okay, C plus plus and Python. Okay, that's good. Lau Chor, yeah. Okay, can. Very well. Okay, so these sort of things, it shouldn't be too much of a stranger for you lah. It's basically just an open API, so you can download the data by going to api.coronatracker.com, and then you can download the data to build your own model. Okay, and then the next thing is scalability. So I give you maybe 30 seconds. Take a look at this. See what difference that you can spot. Now, if you can see this, right, all of these websites, they look similar. So there's a Brazilian report, there's Berita Harian, and then there is Philippines COVID-19, and then you have Doc to Us. So this help us to grow our website and user base because we allow other people to use our data. Yeah, so one of the strategy, right? So most of you in your third year, I wouldn't speak to you like freshies like that. When you go to work, you always have to think about how do you gather data from external sources. Yeah, API is one of the ways to do that. Okay, and then the next one is unstructured data. So we have a lot of unstructured data. This one I mentioned to you before, news articles, and then we have tweets. We gather tweets from different official sources as well, and also we have travel advice from the other sources. So from the data standpoint, what I'd like to share is the cost. Okay, now again, give you 1 minute to look at this table. Okay, so this is a bit different from the typical web applications or website that you have seen, right? You must be thinking, wow, if you want to build a Corona tracker website, you need to have like 100 million views. We usually have about 1 million views per day at peak. But nowadays, because everybody is numb and fatigued by the numbers, so they got a bit bored already. So the numbers drop. And if you look at the infrastructure cost, it's actually very cheap. Yeah, we spend about 400 plus ringgit per month, and most of the cost comes from the replica here. So we have a front end, and then we have a back end scripper, and then we have a MySQL. So the setup is actually super easy. And for you, right, because you're engineering students, you probably won't have to do those things like, let's say, front-end web development or mobile application development. But chances are you will have to uh, you have to you have to do some sort of database, yeah, data access. Okay, and next one is the software and framework that we use. Okay, now if you look at the software and framework that we use, right, we have Nuxt.js, Tailwind, Netlify, Node.js, GitHub, Python, and Visual Studio Code. These are the software that we, sorry for the presentation here, is actually zero. Okay, the total cost is zero, some formatting issue. And uh, all these software that we use are open source. Yeah, Nuxt.js, Tailwind, Netlify. Netlify is not 100% open source. It's a premium service, but if you use it for, let's say, like social projects like this, or if you use it for low volume, right, you don't have to pay for it. Yeah, Node.js is Node.js is also open source and free. GitHub, Python, and Visual Studio Code. Yeah. All right. Next up, team members. So if you're working in the data environment, right? I'm sure that later on when you go to work, yeah, more complicated results. Yes, correct. Yeah, later on when you go to work, and you will have to work in. We are seeing a lot more companies. It doesn't matter what industry, whether it's oil and gas, whether it's finance, banks, whatever. They have increasing numbers of the data science team. Okay, so what happens is that when you work in the data science team, you need to understand the team members consist. So in Corona Tracker, we have data scientists, data engineers, product engineers, and full stack engineers. So let's say if you're a civil engineer, right? If you work in the data science team, you will have to deal with data scientists and data engineer. If you are mechatronics, let's say, right? And you will have to deal with the same settings as well. Full stack engineers are those who build web applications. The difference between full stack and front end and back end is that front end is usually handling UI, user interface. Back end is usually handling the code. Yeah. Okay, so these are the team members that you will be working with. And so let's take a look at what is next for Corona Tracker. As you know, our country is currently suffering from a lot of damage, a lot of aftermath from COVID-19. First of all is our finance, and then second is our travel, tourism, and then the third one is our F&B, food industry, and then number four is our retail. Number five is oil and gas, and number six is entertainment. So like those pubs and bars. So what we are going to do is we are going to build some sort of work with the government very closely to build some sort of applications and use cases to deal with or to help this industry to recover. So we have, if you go to WHO websites, right, you will see that we have publications. Yeah, we publish this paper, Worldwide COVID-19 Outbreak Data Analysis and Prediction. My name is here. Our team published this paper, so you can take a look to understand the entire data structures, architectures, everything that I've mentioned, but in a more academic format with all the related or relevant references. Okay. And then the next thing what we're going to do is we're going to, actually we have already done that. We work with Microsoft and AWS to provide an open data platform so we can collect the daily statistics for all countries, which is what we have already done. And some of the research paper that is published under CORD-19 initiative. So most of the people, they publish their research results and paper is their academics. So they are not really familiar with with data science and all those machine learning AI. So we are going to help them with that, and we are going to work with radiologists to identify COVID from their early X-rays and CT scans, and also Apple and Google mobility data set to understand how people move around during this pandemic. Okay, and these are some of the ongoing research lah. Academic curves by country, economic impact. Probably you guys will be uh, too interested in this one lah. Just for you to understand how we actually gather data from different sources. COVID-19 by demographic factors, climate factors, transport networks. Yeah, so different use cases and different angles perspective to look into it. And from a more psychology and social point of view, right, we want to address. So all these are just research papers and open data sources, right? What gives value is that how do we actually implement these and put it into real world use? So a more severe social problem is like recessions, depressions, suicide, and also robbery. Yeah. So in a nutshell, what we are going to do is we're going to focus on open data, research, and implementation. And therefore, we have this platform called COVID-19 AI. Yeah. So if you go to this website called COVID-19AI.org, this is basically how we address the three issues lah. Okay. And this is our official platform partners, Microsoft and Azure. They help us to uh, they host our entire platform, and our research areas covers natural language processing, which is the area that I'm interested, computer vision. So if any of you wants to do things related to CV using computers, using image to recognize, to identify COVID, or statistical modeling. If you're mathematicians, statisticians, you're more than welcome to join us as well. Yeah, so CV or computer visions, and also we are venturing into audio. So if you are good in sound, like we try to build a models, and we are currently testing how do you identify the coughing, COVID-19 from a coughing sound of somebody. Okay, and yeah. So who we need? We really need a lot of people. We need a lot of talents, data scientists, data engineers, machine learning engineers, AI developers, researchers, mathematicians, statisticians, modelers, and anyone who is interested to contribute to research using AI to combat coronavirus. Okay, so here are some interactive data exploration. So these are our results, some of the things that we have done so far. This is the outbreak trend over time. So by using these, right, we can actually look at the curves, and we can compare ourselves with other countries so that we know, not just ourselves, basically every country can compare with each other's different cities. And this one is look at the distributions, right? So by doing this, we are able to know whether we are flattening the curve or we're still on an exponential growth, and how we are doing comparing to other countries, other cities that is of a similar scale. And also we want to do simulations. Okay, so we plan to do different types of simulations that allow you to use uh, basics epidemiologies parameters, and also estimate the stress on our healthcare system based on the populations. Yeah. Okay. And any questions so far? Okay, no questions there. Let's continue. So Mark Zuckerberg always say, right, he's famous of saying this, right, move fast and break things. But in COVID-19 case, we cannot afford to do so, right? We want to move fast, we cannot afford to break things. So first lesson I learned is move fast, but don't break things. So I know this is an era that everybody has been saying fast, 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 fast. You need to do things quick, especially in startups or tech scene, right? But fundamentally, you need to move fast, but move steadily. Okay, don't break things because life is at stake. Yeah, we are. You see, it's 1 year plus now, right? It's 1.5 year, so to speak. We are close to our first MCO anniversary, and we are sort of under control, but you see, it's almost impossible that we can go back to how things were in the past. Yeah, so it's something that's very scary, and most of us is our first time in our lifetime. So move fast, but don't break things. Okay, handle things carefully. Second thing is focus on the application, not the technologies. Now, most of you are engineers. The difference between scientists and engineers is scientists are the people who ask questions. Okay, scientists usually they came from like, for example, myself, right? I'm a data scientist, and once I felt I'm satisfied with my scientific research part, we'll go to the philosophical part. So scientists are troublemakers. We always ask questions, but you are engineers, so your role is very important because you want to focus on solving problems. So you need to focus on the applications and not the technologies. So create technologies, not focus on those fancy things like, oh, this is the latest machine learning model, this is the deep learning, blah blah blah, and stuff. Especially with buzzword like AI. AI basically is just the application of machine learning models in real problems. Yeah. So don't be so obsessed with the technologies, really. And last but not least, start small, think big, and scale fast. And you guys are students, all right? So a lot of times you think too small. Okay, you start small, that one is standard, right? In corporate world, in business world, is they like to start big. They talk very big, but end up their delivery is very small. If you're students, you definitely will start small, but you think small as well. Yeah, this is something that I would like to advise you is as a student, start small, but think big and scale fast. See, the first point I tell you not to move fast, right? But I tell you to move fast, but don't break things. The last point I tell you to scale fast. Your scalability needs to be fast, right? Your movement, your things, everything needs to be steady. But most important thing for you is I want you to think big. Okay, so these are some of my contact information. And next up, we'll talk about data science. Okay, Okay, so that's all about COVID-19 Corona Tracker. So I'll give you 1 minute or 2 minutes. Feel free to ask me any questions. If not, you can take a short break and then we'll continue with data science. My data science part I will finish around maybe 11:30, 11:40 like that. So give you some time to ask questions lah. Millennium, you have something to say?
Yeah, actually, I kind of have a question that kind of popped up just now,
Sure,
actually.
go ahead.
Yeah. I'm pretty sure there has to be some sort of like a very distinguishable difference between a data scientist and a data engineer, right? There
Yep.
has to be, yeah. So like, what's like I think the clearest difference between the fact that one is a troublemaker, one is the problem solver.
This one I'll explain in a short while. The four roles in in the data science team, but basically, I would say data engineer is slightly different from EE mechatronics engineer. That one I'll explain in a short while. But what I want you all to know is that data or data science, right, itself is a layer. Yeah, it's not an industry. It's not a pillar. So you cannot like you, let's say for myself, if I'm a data scientist, I don't work with I don't work with mechanical engineers, right? A data scientist like us pretty much have is useless. Yeah, so this is one thing that I want you all to remember. Your domain knowledge is very important.
I see, I see.
Mm. Okay, all right, let's take a water break. Okay, 2 minutes. Okay. All right, welcome back. And let's continue with our second part, which is data science, okay? So, what is data science? A lot of people has been asking this question. Like, you hear a lot about data science, even if you ask your lecturers, your friends, your supervisors, yeah, if you go for internship, everybody will give you a different answer, and all of the answers are funny. So, uh, funny in a way that everybody's answer is different, lah. So that's why it's funny. But you just need to remember, right? When it comes to data science, you just need to remember the three key elements in data science. Okay, all data scientists, no matter how good or how bad they are, fundamentally they need to know about these three things, which is programming, mathematics and statistics, and domain knowledge. Programming is basically skills for us to acquire, manipulate, and clean large amount of data. So when you have a lot of data that you need to do, right, you need to process, you need the help of programs. You can't walk away with programs because uh, your engineers, like, I don't have to worry about you hate programming. But in case some of you don't like programming, right, you won't have to write programs every day. But you need to write scripts because sometimes, like for example, your data set is too huge, like COVID-19 virus. We are not advisable to handle this manually. Like, can you imagine Excel to handle a database of 1 million records? You can't, right? So that's where programming comes in to help. We normally use Python at work. Now, if you're coming from a more academic or research background and you have learned programming languages like R, yeah, you can use R as well. And the second one is mathematics and statistics. So maths and stats knowledge is for us to pick the right model. So I'm pretty bad at mathematics and statistics. That's why I'm not an engineering student, right? I become a IT student. I didn't even choose computer science because too much mathematics involved. Never did I know that shit, data science and PhD also all about math. So anyway, I managed to cross the obstacle because when I was about to graduate my PhD, my supervisor says that, hey, if you don't know how to write mathematics notations, you're not going to graduate. So I was forced to learn that. Our turnout is not that bad. It's not that hard. If you know programming, mathematics is not hard. At least for me, yeah. So for you, engineering maths is definitely a lot harder than the maths that data science is using. So last but not least, which I consider the most important thing in data science, which is the domain knowledge. So domain knowledge is how good you are in a particular field. So I think Millennium also asked the same questions, right? It's about asking questions and finding answers. In today's world, finding answers is easy. Okay, super easy. You just go to Google, go to Reddit, go to Quora. You can get your answers that you want. But forming hypothesis, formula hypothesis, interpreting results, asking the right question, that is the hard part. Yeah, so and that requires domain knowledge. And domain knowledge is not something that you can short circuit, like you can go for 3 days class and pick up a lot of domain knowledge. It needs a lot of implementation and practice. Yeah. Okay, so these are the three main skill sets that you need to have if you want to become a data scientist. And let's look at the emerging jobs of data science in 2021 so that you understand what are the different roles in data science. So the first one is, the four positions in data science is data engineer, data analyst, machine learning engineers, and data scientists. Okay, these are the four positions in data science. And let's take a look at the first one, data analyst. Okay, every company needs a data analyst. As long as you have data, you need data analyst. Very simple, because you need data analyst to help you to analyze your data, right? So the job of a data analyst is to translate numbers into plain English. So a data analyst will be able to take data and use it to help companies to make business decisions. So the skill sets that you require are database query, basically SQL, communications, visualization, business intelligence, and also dashboard. So companies that hire data analysts are companies like Citibank, Shopee, Ninja Van. Basically, any companies, any organization that has data, they will need to hire data analysts. Okay, very straightforward. And um, engineering students, I don't foresee you to become a data analyst. But if you want to work in a data analyst positions, right, you can strengthen your BI skills, business intelligence skills, and visualization skills. This is usually what people are weak at. And if you look at it from the other side, right, if most of the people who are looking for a job that does not know these skills and you know this skill better than the others, the chances of you getting a job is a lot higher. Second one is data engineer. I think this one, just now we were discussing it. Data engineer is a little bit different from other engineers because they need to do some design, okay, architectural design. So those of you who are from civil, you know, your your blueprint, right, your plan is very important for your entire building. Yeah, if any part of your blueprint went wrong, your whole building will collapse. Same goes to data engineer. Yeah, so your primary skills is data architecting. Okay, you need to design and plan a data architect for your organization. So look at the companies that hire, like Grab or AirAsia. Imagine AirAsia has a data platform and this data platform goes down for 30 minutes. How much sales, how much loss is going to incur? And imagine you're working at Grab, right? And the entire Grab car, Grab taxi network is down for 30 minutes. How many people are going to be stuck on the road? Yeah. So the job of data engineer is very, very important because they develop, they construct, they test and maintain the data architectures, and they manage large scale databases and processing system. So again, the word scale here is, it means like when you have small amount of users, usually you don't have to worry. But let's say your companies, your data, your transactions grow from 1,000 to 10,000 to 100,000. This actually matters a lot. So the skill sets that it requires are SQL, API, and also server management skills. And next up, we have AI machine learning engineer. So this one probably I foresee more of you will become somebody like that in the long run. They are not immediate. I'm not expecting you to graduate and become a machine learning engineer straight away, but in long run, let's say you have done well in your field, right, and you found some interest in machine learning, and you can become a good machine learning engineer. Your job is to write programs that enable machines to take actions without specifically directed to. So focusing on AI as your ultimate goal. So you have skill sets like mathematics, statistics, data modeling, supervised learning, unsupervised learning, and deep learning. So these are some of the hot topics lately. And companies that hires, basically any companies that has a lot of data, they have R&D arms, right? Like for example, Uber, Baidu, Samsung. Samsung does a lot of machine learning and deep learning as well because they're trying to play a catch up game with Apple, so they need to fix their earphones, they need to fix their voice recognition and so on. And if you use an iPhone, right, you look at what do you call it, Siri. Yeah, Siri is actually a very complicated and complex component. So when you speak to a phone, you need to take your speech and convert into digital signals, right? So you have your sound wave, and then you convert into digital signals, and from these digital signals, you need to convert them into text. So you need to convert human speech to text first, and then from this text information, you try to extract the intention, their intent, and the keywords from this speech, and then you need to go to do a database retrieval to get the data, the answers that you want, and then return it as a string. And now you need to form the string to be as generic as human as possible so that you can ask the phone to read it out for you. And when you read out is another problem called text to speech. So it's a very complicated component, which, yeah, it takes a lot of it takes a lot of investment into building one. Right? So learn how to appreciate that. My point. So that's what a AI developer, machine learning engineer does. Okay. And last but not least, you have data scientists. So data scientists in the data science team actually is like myself, right? We are more of a generalist. We have a broader skill sets. We are not really specialized in anything. Like we know how to analyze data. We know how to build data platform. We know how to build machine learning models. But we are not so into specialized into any of them because we usually look after the entire workflow and entire entire project lah. Yeah, we are more not to say we are higher level, just generalists. Okay, so we combine programming, mathematics, and domain knowledge to extract insights from data. And our main job is actually to build models to answer business questions. Like the other three role, right? Especially like data analysts still find some answers, but usually engineers and machine learning engineers, you don't have to answer business questions. You don't have to deal with the business people. But data scientists, we need to. So we need programming, mathematics, statistics, database query, visualizations. We need to know how to tell a good story, and we need to have strong domain knowledge, and also we need to know machine learning. And that's why data scientist is a bit like a unicorn. Companies that hires them, like they really pay a lot of high salary to hire these people. Okay, now we talk about salary. Let's look at your salary scale. If you want to become an analyst, right, your junior salary starts from about 2.5 to 3.5K, lower than engineer. Engineer, I don't know, what's your starting pay now? Have you started looking for a job already? Yeah, let me know. And if you are confirmed, right, your as a data analyst, your salary is about 3 to 5,000. They pay quite well. Depends on the industry as well. And if you become a senior analyst, you are handling more difficult projects, more projects that requires a lot of insights, then your salary will be about 5 to 7,000. And you want to become a manager, right? You will be like 10 to 12,000. So managers usually they lead a team, they will handle a project by themselves. And of course, finally, the director of analytics is the director of a company. So when you call directors, you are on par with other management in the companies as well. Okay, so this is the ladder of an data analyst. Now, if you are looking at data scientist, it's relatively smaller, less complicated, less complex, because data science is still a very new industry in Malaysia. If you look at the universities, I think uni starts to offer it about 4 years ago. Yeah, about 4 years, 4 to 5 years ago, like 2015 that time. And then so we haven't gotten a lot of maturity. Like if you are junior data scientist, your salary is about 2 to 4,000. If you are data scientist, you have mid-level, like, you have 2 to 3 years experience, your salary is about 4 to 5,000. I have a lot of students in working as a data scientist in AirAsia. Their salary is pretty well as well. They get paid well. And then if you're experienced, you become a senior data scientist, about 5 to 8,000. We usually don't have a manager role yet for data scientists. I'm not sure why, but I think it's because we don't have that many senior people, and we don't have that many senior people that wants to work as a manager lah. So, but senior data scientists or the most experienced data scientist in a team usually is a team leader as well. So their salary is quite high, 5 to 8K. And if you're a chief data scientist, it's about 10 to 15K. And it can go higher, it's just that those are outliers. I've seen people get paid like 50,000 a month. And that's because they're funded company, and also their salary is on par with other C-level like CEO, CTO. And if you don't want to become a chief data scientist, you can still become like chief information officer, like CIO. One unique thing about data analysts is that data analysts, they usually work in a specific field, like they work as a social media analyst, web analyst, etc. Okay, so these are the key difference. All right, so before I go into the data science basics, any questions? Okay, seems like there's no questions. Let's continue. So why does everybody suddenly talks about data science, right? The main reason behind is we have a lot of data. Simple, short answer, stupid answer. from me. And those data comes from your existing corporate system. So let's say you have a HR platform, right? So this every company will have all these systems, HR platform, sales platform, finance platform, sales system, finance system, procurement system, vendor systems. And these systems, they generate a lot of data. Okay, you have customer data, you have product details data, you have transaction data, and you have uh, emails, and you have customer feedback data as well, right? So you have all sort of different datas. And in a corporate environment, right, in a corporate settings, usually what we do is we use these sort of tools or software to analyze this data, or not to even say analyze that, to handle and massage, prepare reports from this data. So number one is Excel, number two is Power BI, and number three is Tableau. Okay, these are the three different things, tools that we usually use. Most companies use Excel and Power BI if they are Microsoft fans. But here comes another problem, right? These are just some of the normal data, I'll call it normal data that you've seen, right? Ordinary data. But what about you have something like this? I'll give you 1 minute again. Yeah, take a look at this. Take a look and let me know in the chat. If you have these data, right, how are you going to analyze them? You are engineers, right? Yeah, you solve problems. Okay, give you a minute. All right, let me see what's your response. That's a lot of data. Yeah, so many millions, right? You wish those that's why these companies worth billions. Yeah, they're unicorns, they're $1 million company. Hey, but that's not the answer I'm asking. The question I'm asking is how are you going to analyze those data? Don't tell me all the millions. Okay, so imagine if you as I asked you to wait for 1 second, 1 minute, right? There are 59 million messages sent across the network of Facebook. So you have Instagram, you have messages, you have WhatsApp, and then you have 1.2 million views on Twitch. Let's do something that you guys always do, like Instagram. Okay, so almost 700,000 Instagram scrolls, and then 1.3 millions logging in, and 4.1 millions on Google. This is what is happening in 1 second. Okay, well, I keep saying second. 1 minute, 60 seconds in the internet sphere. Okay, and those data that is generated from here is not directly related to those systems that we saw, but it's more towards like entertainment, social, communication, work, shopping, and relationships. So you cannot use Excel to handle this data, right? Obviously, Excel only has 16,000 columns and 1 million rows. Like, are you going to have one new spreadsheet every 60 seconds? Obviously not. And even that, you can't handle things like, for example, Twitch views, yeah, because it's more than 1 million already. So Excel is good for spreadsheet, but it's not good for data like this. And this is actually where the important data of our social interaction is, right? So what we do is, Excel is unable to handle large amount of data. So this is one of the most important pitfalls. Later on, you'll know, because when you go to work, right, a lot of people will say, oh, I can use Excel to do this, I can use Excel to do that. But it's very slow and not effective. And Excel also cannot handle unstructured data, basically any of these, right? Photos, music, videos, and text. Excel cannot handle this at all. Yeah, Excel don't understand. So we need programming language to handle unstructured data, and also we need programming language to help us to build machine learning models. And this is where it comes back to the question that I asked you earlier. What sort of programming language that you have learned before? So in data science, the most common one that we use is Python and SQL. I'm not sure how many of you have learned R in your course, but R is, in Malaysia at least, right? It's not so widely used. Yeah. So Python is more important. and more popular. And then second one is SQL, of course. SQL is a special language for you to interact with database. So Python is good because it's designed by computer scientists and used by programmers, web developers, and scientists. Not just data scientists, but other scientists, they use Python as well. And it's super beginner friendly and the syntax is simple. So you have written Python code before, right? So you know that it's not as troublesome as other programming language like C or Java. And it's often used in deployment and production as well. We actually use Python a lot for automated testing, unit tests, and also production code. Because Python, you can write a web application website in Python, but you can't do it in R. And since Python is the number 2 most popular programming language in the world, it definitely has a strong community support. And what it translates to your human words, layman terms, is that when you ask a question on forum or Stack Overflow, you can get answers easily lah. Okay, you can easily Google answers using Python. And to give you some example, do you know what is on the left hand side? Okay, left hand side is a picture, is a image of a black hole. So this is rendered using Python. And on your right hand side, this is a spaceship, SpaceX, Elon Musk. And they use Python for a lot of testing as well. You can see the blue screen here, right? Blue screen is actually written using HTML and CSS and JavaScript. Yeah, so it's a very modern spaceship that use a lot of web technologies as well as modern programming language like Python. So this is what I meant, SQL, standard language to interact with database. So we use SQL for relational databases, yeah, RDBMS. We use it to execute queries against database so that we can perform CRUD tasks, create, retrieve, updates, and deletes. Yeah, these are the common things that we need. Okay, so what can you do after learning data science? Okay, now when it comes to data science, right, we always use data science to answer questions. Okay, and the type of questions that we are answering are these 3. Is this A or B? Right? Is this item A or B? Is this data point A or B? How much or how many? And also, how is this organized? These are the 3 types of questions that we always ask in handling a data science project. Okay, let's take a look at them. First one, is this A or B? Is this A or B is actually a classification task. Classification task in data science means that we try to classify a data point into a category, okay, into a particular category. So what we want to do is we want to assign the right class to the data points. For example, will this employee leave next month? Yes or no? Which advertisement is more effective, version A or version B? What movie category is this? Thriller, romance, or adventure? If you go to Netflix, right? If you have signed up Netflix, you can take a look at their genre, their movie categories. They are not using some high-level categories that we use in normal movies like thriller, comedy, romance, adventure, that sort of things. They are very fine-grained and subcategories, and this is what brings Netflix the success to the current success state. Okay, and so classification is basically for us to assign the right class to the data points. And the second type of questions that we want to answer is what we call how much or how many. How much or how many is basically a regression technique that we use. So for classification, right, the output or the outcome is always a label, yeah, yes or no, which A or B, thriller, romance, adventure. So these are labels. But in regressions, the output is always a value. Yeah, it's a number. So for example, we want to predict how many, what would be the temperature tonight, or what would be the sales for our next quarter be, or what would be the price of a real estate property. Like if you want to buy a house in KL, what would be the price be in the next 3 years, etc. So all these are done using a technique called regressions. And regression basically for us to predict the value based on our input variables. Okay. So the 2 techniques that I've shown you here, right? This is what we call supervised learning. Yeah, the reason why they are supervised is because your output is fixed. Okay, you already know what is the output that you want. I want to know what's my temperature. Okay, I want to know whether my employee will leave or not. I want to know which advertisement is more effective. You already know what sort of answers that you're looking for. That's why they are called supervised learning, and they have a set of training data. You basically need to provide training data in order to get the output. But there are some situations or some circumstances that we don't have the output that we want. We don't know what is the output that we want. We basically just want to look at our data and make sense out of it, right? That's where we use a technique called unsupervised learning, which is a clustering method. A clustering method is for us to group items together based on their similarities. So if imagine these blue dots are your customers or uh, your users who are watching the same movies, right? You can group them together based on the movies that they watch so that they know who are they. If you are a shopping center, you are e-commerce stores, you can group them based on the products that they bought. You can group those products that are similar together, or you can group printers in the same way as well, right? So let's say these are the printers that fail in 3 months, 6 months, 9 months, 12 months, and 18 months. And you can look at the printers who fail in 3 months and try to understand, hey, how come all these printers fail together, fail so fast? And you look at the common things between them is, oh, okay, because they're using the same brand of power supply. Okay, so this is clustering. Clustering is for us to group similar items together. Okay, so I've explained to you the three most popular business questions that we use in data science. That takes up about, I would say, 80-90% of our models, usually, unless other more advanced and more chunky questions, which are not directly related to these business questions, but the technique that we use is always the same. Yeah, it's either supervised or unsupervised method. Okay, all right. Before I go on to the next part, any questions? Okay, Brian said you need a specific database. Yes, correct. So if you're handling unstructured data, you need like big data database like Hadoop, or you need unstructured data database like MongoDB. Yeah, you have different types of them. Tinder has more swipes than IG. Adoy. Of course lah. Okay, supervised means you need to provide training data. Unsupervised means you don't have to. The data, yeah, we use Python to collect data, and then we use SQL databases to store. So we have database, data warehouse, data lake. Yeah. Okay, well done. Thank you, Lee Cho. Keep those questions coming, okay? Yeah, it's like I said, it's a very comfortable settings, and I would like to answer more of your questions. Yeah, then just keep saying, keep telling. Okay, I have a couple more slides, about 10 more. Yeah, then we can go into Q&A with in-depth discussion. Okay, so let's take a look at how data scientists manage our data science project. There are many different, I would say, metaphor, different project management skills out there. But in data science, we have a specific one that we use called Awesome Framework. Actually, this sort of answers the question that you guys were asking before, right? For example, how do you gather your data? So the first step is to obtain data. Without data, you're going to do anything, right? So obtaining data is for us to gather data from different sources. You get it from website, you get it from CSV file, you get it from Excel, databases. So this is the obtaining stage, the O stage. Yeah? And once you have obtained those data, right, you need to clean the data before you can store them. Okay, or you can store them first, but you still need to clean them before you can use them. So the process of cleaning data is what we call the scrub stage. So we clean data to a machine readable format. Sometimes you have to understand, right? Machine does not understand text. or image or videos or audio. Machine does not understand numbers even. Computers only understand signals. But okay, we take it as an assumption that signals and numbers are sort of okay for computers to understand. So whatever you need to explain to a computer, right? You need to put it into a format that computer understands. So it need to be in a number form. So like, for example, you want to test somebody's IQ. You cannot say, oh, this person is very smart. Computers don't understand what is smart. But you have to say, oh, this person IQ is 120 and normal people, their IQ is 100. This is considered smart. You know what I mean? Yeah. So the second stage is to clean the data. And then after you have clean up your data, right, you need to put it into exploration stage. You need to find patterns and trends inside those data so that you can make some correlation studies. You can make some, you can test your hypothesis and you can come up with a conclusion. And this OSE stage, right, takes up about 70% of our time in data science. Then only we get to build model. A lot of you think like, oh, data scientist is very cool. Yeah, you build AI models. Yeah, first thing first, you want to do artificial intelligence. That's not always the case. Yeah, usually what we do is we spend a lot of time understand the data, cleaning the data. Then only we put it into models, and then finally we explain the models and the results. This is how we usually work. Okay, and the 5 stages when we combine it together is OSEMN, which is what we call the awesome framework. Okay. All right, so the last bit of today's talk is to give you some actionable tips to teach you how to get started if you want to pick up data science. Like I say, you have domain knowledge, you are going to become engineers. Okay, don't tell me you want to become data scientists after my talk. All right, please don't. Your parents are going to kill me. But you can be an engineer who knows data science very well. This is something that is very unique, and I can guarantee you that you will get jobs faster, better, and get paid higher than your other hundreds of friends who did not come to the talk today. Okay. All right, first thing first, get your hands dirty. As an engineer, I don't have to tell you too much about this. Just make sure that you always put things into practice. So go to this website called Kaggle, yeah, KAGGLE.com. Okay, KAGGLE.com. It's over here, right? Kaggle.com. KGGLE. Inside Kaggle, you'll find all the codes and data that you need. So you have public data sets and notebooks that gives you all the data sets that you want, the code that you need, and also it gives you money. Data sets means your ingredients, right? Code means your recipe, and money means your fuel, okay, your oil to keep you going. So the 3 most important thing in data science. And when you go in, right, you just need to go to the data set section. You can see that there are a lot of interesting data sets. And these are real world data sets that you can just download and use. Even if you're preparing for FYP, right, you can go to kaggle.com and download some data sets and use it. And after you have downloaded the data sets, what you're going to do is there are also notebooks that teach you how to analyze those data. Basically, some professional data scientists or some working data scientists like myself, we write our code and then we analyze the data and then we upload it there to share with you all. Okay, and the third one is to benchmark your skills. So this is where you get your money. Basically, you take part in competitions. Now you see 500 teams, right? Your first prize is 50,000. Some of the competitions are not that hard. There are just many teams. Some people, they join, like our students, they join it because they want to get the data. So who knows, right? Your skills is good and you can walk away with 200,000 ringgit. Yeah. Okay, second thing that you need to do is you need to pick a niche. This is something that is quite abstract for university students because in uni you learn everything, right? Hambalang also you need to learn. But in data science at work, right, you don't have to. Okay, life is not that difficult sometimes. You just need to go into a particular area that you would like to specialize. Okay, if you love visualization, you love drawing charts, then go to visualization first. If you love business, you want to know how business work, you go into business analyst. Now you have done too many engineering in your study, so don't go data engineering. But if you really love networking, you can try. Like myself, because I don't like numbers, I don't like arts, right? So I have no choice. I pick up text mining. Yeah, that's my first choice. And after that, I realized that shit, text mining is so hard, so many things to analyze. So I pick up machine learning to release my burden. Yeah, to reduce my burden. Okay, so there are many specialized areas in data science. If you don't know them, just drop me a message on Twitter or LinkedIn. I'm more than happy to assist you with that. But most important thing, don't try to master everything at once. Yeah, that doesn't work. And most important thing, forget about big data. As a beginners, as a students, big data got nothing to do with you. All right, only those big companies, industry projects, then they will need big data. As a start, a small data is good enough for you to begin with. Okay. All right. Third, show off your capabilities. Now, this one is specifically for for students. You don't like to write documentations. You only, when you think of graduate, you basically think of resume. Resume is not enough. You need to build a portfolio. All right, a portfolio that tells some extra stories about you, to show more about your projects that you have done, and to basically let people understand you better. All right, let people understand you better, and if you don't believe, right? I know you always don't believe the speakers. I show you something from the forum. This guy worked in Fortune 500 companies for 5 years, and the managers always brought out the portfolio and asked questions about the projects inside. And this guy say, I read in multiple sources that you should create a portfolio website to showcase your project, increase your chances of getting hired. See how important is portfolio, and they're all well recognized comments. Okay, I didn't screenshot from anywhere. If you still don't believe, I'm sure that you know this guy, right? Yeah, Uncle Roger. I can't believe you don't have a portfolio. Even I have one. Your biggest takeaway today probably is before Uncle Roger become a stand-up comedian, he was actually he's still a data scientist. It's just that he focused more on stand-up comedy nowadays. Focus more on his fried rice, yeah. So Uncle Roger, he is a stand-up comedian, and he is also a data scientist. This is his portfolio. He does a lot of deep learning, Keras, TensorFlow, fast AI stuff. Okay, so before I enter Q&A, let me give you a quick recap. If you want to learn data science, right? Data science is interesting because it's a multidiscipline subject that involves programming, mathematics, statistics, and most important thing is your domain knowledge. And a major part in data science is about building predictive models that help us to gain certainties while making decisions. Data science is basically just a decision science, okay? It's nothing else but helping you to make decisions, or you build models to help your companies, to help your boss to make decisions. And building models takes inputs and predict the output. It requires human effort to label the data for training. That's why it is a supervised method. And you can also use clustering to group similar data points together without training data. And this is what we call the unsupervised method. Now, no matter what, without data, you are just another person with opinion, whether you go with meetings or you go for a group discussion. So always make sure that you bring data with you, right, to help you to improve, I would say, right, to improve and increase the credibility. Okay, so that's my presentation for today. Thank you for your time. Thank you for staying with me. And yeah, let's do some Q&A. Ziteng asks, how is clustering usually done? Okay, clustering is basically like, let's say we have, how many of you here? We have 12 of you here, right? So you want to know how many groups are here if we want to group us based on our eating preference, okay, based on our eating preference. So your domain knowledge comes in place. You know, some people they are vegetarian, some people they are non-vegetarian, some people they are maybe vegan, or maybe like they are allergic to seafood. Okay, there are three types of people: vegetarian, non-vegetarian, and seafood allergens, right? But you don't know how many of them are there. You only know that roughly there are these three types of people. So you run a survey and then you group them together. And these people that fall under this individual category, they will be grouped together. Okay, so this is how clustering is done. It's basically an algorithm, not so much of a model. Yeah, the algorithms that iteratively group people with similar features together. And is there a limit for SQL in storing? Technically, there isn't. Technically, the limit is your hard disk space. So as long as your hard disk can store, you can always link up. It's just that there won't be a single SQL database that's like 100 terabytes. If we have 100 terabytes that we need to access, right? 100 terabytes of data that we need to access, we usually will have some strategy to divide and conquer and split them into smaller ones so that it doesn't affect the speed.
Dr. Lau, I think I have another question for you actually. It does look like you do need at least some programming skills, right? In order to fully grasp the whole picture of data science, right?
Mm-hmm.
Yeah. So does this imply that you at least need to have very strong basic programming skills?
Strong and basic don't come together lah. You need to have a solid understanding like basic programming, basically like loops, uh, if else statements, and also variables data structures. Yeah, so you guys are science and engineering students, so your basic understanding will be better than normal people. But you don't have to understand all those programming metaphor like agile methods. You don't write programs when you are working on data science projects. You write scripts only when it comes to taking your project to production, right? Then only you need to write some programs like a website, but usually not your job as well. Yeah, so your job is to build them, as in data science job is to build the models and find the answers. And the script is useful when we have large amount of data. Yeah.
I see, I see.
Mm. Like
What?
for example, right, Chinese New Year, you want to scrape Lazada and Shopee website to know which item is on sale, or where can you find the cheapest soft drinks. You can do it manually, but you're not going to go into hundreds and thousands of pages to scrape those information, right? So you can write a script to do that for you. So that's an example of using Python. If you want to build your own portfolio, you can go to github.com. But if you want to get those data set, right, you go to Kaggle. Yeah, these are the two main websites that we use.
I've also put the actual like Kaggle link. So if anyone wants to like have a look, you can go to there.
Come again?
I've put the link to Kaggle in the chat as well. So
Oh, okay, okay. Yeah, yeah.
if anyone wants to go and have a look, you can go to that link. Where was I? Oh yeah. To continue on with my question just now.
Yep.
What about say if we were to handle a database? That will also need at least some I'd say very good fundamentals, right?
Yeah, if you need to handle database, then you need to have a good SQL skills, the basic SQL. Yeah, if you want to read up online, right, at least you know how to do select command. Yeah, SQL select is, and then join. These are the common things that you need to do. Yeah, and will be quite sufficient. Because the problem is to pull the data. Yeah, to write the data sometimes is data engineer's job, or you can do that lah, but in usually those company, especially like fresh grads, you unless you join a startup, otherwise you don't have to do all those things.
I
Yeah,
see.
knowing how to query a database is good enough.
Okay. Then what about if I say that I have able to handle Excel? Can that be transferable? Or I mean the skills?
Excel is like a very common skill nowadays. Like when I'm at your age, right? Excel is something like, wow, you know Excel. But nowadays, every university graduates, I think some of the high school students also they learn Excel. So it's not something. It's something that you will surprise people if you don't know. Not like something that you surprise people if you know. You know what I mean?
Mm-hmm.
Yeah. So you should learn how to analyze data in Excel, like how to build models, how to use different kind of visualization. Then that will be very useful. Yeah. Not just basic Excel commands. So when you're dealing, you won't deal with like million rows of database data sets every day. Like if you look at your experiment data, right? Your data set is very small only, right? 100 rows, 200 rows, right? So you can use Excel for those tasks, no problem.
I see, I see. Any more questions from the floor? We still have quite a lot of time before 12. Okay, we have another question from Ng Zeteng. So he says that he has a data set of spectrograms. So is it possible to cluster them with a good accuracy?
Okay, good accuracy is very hard to tell unless I look at the data set. But again, clustering is It's very hard to determine accuracy for unsupervised tasks because you don't have a target, you don't have an output, right? You don't have a benchmark. But yes, you can use clustering for spectrograms. What sort of spectrograms? As in, what are you trying to analyze with those spectrograms? Yeah, machinery vibrations, right? Yeah, you can the one. So you can cluster based on the different types of like frequencies or uh, time series lah. You split them into different beans also can. That's what we usually do with the audio. Any other questions? While Ziteng is finding an example.
Any more questions while we wait? Yes, put the sample in already.
Yeah, correct, Ziteng. So that one we usually cluster it based on the accuracy. Sorry, no, frequency. Yeah, you can use this technique. K-means clustering, and then you define your features. See what are your inputs. You start with small sets of input, like 2 to 3 different inputs, 2 to 3 dimensions. Yeah, and then you grow the dimension space, and see whether it helps to improve your accuracy or not. Yeah, good. All right. Thank you. Thanks for the question. This one is FFT. Yeah, you have done the Fourier transform already.
Oh, wait, this is Fourier transform? Oh, okay. Oh,
Yeah, anything with deep, right? You avoid that at the very beginning first, and you don't have to use so advanced chunky technique at the beginning because you don't have a full, like if I were to do this, right, I have better understanding in data science than you, but I have less understanding on the problem than you. So I will have to study in depth into the problem that you're trying to solve, right? But for your case is you don't have to use deep clustering. You just need to, like, if you want to compress the spectrogram pixel to a lower dimension, mainly because the dimension is too high, then you can use PCA, right? Principal component analysis, to reduce the dimension. Yeah, you project your input to a lower dimensions, like depends on your computing capacity. Okay, good. Yeah, if you go deep clustering, deep learning, whatever, yeah, it's the performance will be good because you are using some advanced methods and advanced machine computation, but you won't be able to understand the results and explain it.
oh
And don't
yeah.
forget, this is an unsupervised method. That's even harder to explain.
Mm, oh yeah. Speaking of computing power, I just thought of something. Do you honestly need like a very solid like computer if you were to continue furthering on your career in the data science field, or is like
Why?
a
You want me to say yes so that your parents will buy a computer for you to play games with?
Eh,
That's always a student talks. Always. I always got this sort of traps. Ask me to say, yeah, you need a strong computer. So you need a NVIDIA RTX 3080, that sort of things. Okay, now if you are using normal analysis like what I have mentioned earlier, right? You don't need you just need a normal computers lah. If you want something that lasts you longer and your parents can afford, then you buy an entry level MacBook. Yeah, that's okay too. Yeah, a bit more expensive than PC, but those laptops like 2,000-3,000 laptops, you forget about it. They won't last long. Yeah, they're not good. So we usually use MacBook, like entry level MacBook is good enough for students. Otherwise, if you want to spend on PC, also can. Yeah, if you spend on PC, you can get a better specs. Your RAM matters. If you are not using deep learning at all, right? Then your graphic cards doesn't really matter lah. Yeah, it's CPU and RAM matters the most, and a good hard disk lah, SSD. Those are the three things that we look at. Yeah.
I see. And actually, speaking of MacBooks, come to think of it, I mean, pre-pandemic days, I remember seeing most of my computer science friends, they normally opt for MacBooks. Is there like a how do I say this? Like, is there like a reason why it's so common, or it's just
Because MacBook is it has all the tools and command line tools that is very similar to Linux. So the working environment, like if you work as a whether it's a web developer or whatsoever, right? All those tools like Docker, for example, Kubernetes, the environment is very similar. So when you work on the MacBook, later on when you use cloud, right? When you remote control into a cloud machine, you're not going to have user interface. You don't have icons or those things because we need to save resources and bandwidth, right? So you can only use command line. Yeah, then that's where Windows users usually suffer lah.
I see, I see. If that's the case, then why not you just install Linux on your own? Since both Linux and Mac OS, they're kind of like okay.
Yeah.
Yeah. So, so yeah, actually, like, why not just install Linux instead? Actually,
You can, but when you install Linux, you're uni students, you miss out all the fun. A lot of softwares are not there, like your games.
oh, okay, yeah, that would make sense. Yeah, I didn't
Right?
thought.
Makes sense, right? Yeah.
Uh,
I
okay.
play a lot of games during my uni days. I don't study much. Yeah, that's why my result is not good lah.
Oh, okay.
Okay, but this one is recorded, so yeah, you. No, lah, just joking. I'm okay.
Yeah.
Say man of culture. No more lah, man of social media nowadays.
So, any more questions from the floor, or any other like comments or anything you want to like add on? So I guess while we wait, so Dr. Lau, you're currently still in Malaysia, right? Just to
Yeah, I'm
like,
still stuck in JB.
oh, a JB of all places. Okay. Huh. Then is like the situation there like okay for you, or
It's okay. I'm doing things online, so all good.
I see, I see. Okay, okay.
Mm,
So that would mean like uh you and most of the other like I say colleagues are also like work from home, is it?
correct. Yeah. Actually, before the virus, we already most of us work from home. Like, we only go out and meet. Okay. So, I have two parts, right? One part of it is my business. So it's a consulting business. We build products for clients. So we need to go to the site. If not, yeah, training. Lor. Yeah, like teaching and stuff.
I see, I see. Okay. Huh. Then you're pretty much starting the work from home trend way before everyone else technically, right?
Correct. Yeah. Most of the IT people are like that.
Ah, okay. I see, I see.
Mm. We don't really need an office except for meetings.
I see, I see. Any more questions? Any more? Still open until 12 p.m. We have 13 more minutes till we have 13 more minutes till we say goodbye to Dr. Lau. So
It's okay. I mean, if you have no questions, yeah, feel free to. You can always ask me questions afterwards. Yeah, I'll leave my Twitter here, and then Instagram. So anything. I mean, I know you guys sometimes are shy. Then you can ask me in private. No.
yeah, I mean, in our experience of online learning, it's also kind of the more or less the same scenario.
Yeah. Totally understand. Yeah.
Okay, so if there is no questions, so thank you, Dr. Lau, for spending the morning with us. Again, sorry for the technical difficulties just now. Wasn't really
It's
expecting.
okay. Microsoft. Yeah. I totally understand. Even when I speak at Microsoft own event, right, they will have this sort of technical issues.
Oh, is it?
Yeah.
Oh, I wasn't expecting that.
That's why I use Zoom and Clubhouse most of the time.
Oh,
Yeah.
Clubhouse. Oh, okay. Oh, then what about Google Meet?
No, don't.
Oh, okay. Because like just now during the technical difficulties, I was thinking if we really couldn't solve this problem, then maybe last minute switch to Google Meet. I
No
was
need
actually
lah. Might as well ask me to broadcast to StreamYard or YouTube directly easier.
okay. So before we end it, I want to present Dr. Lau an e-certificate as an appreciation for spending the morning with us. So let
Sure.
me share my screen. So can everyone see my screen right?
Yes.
All right. So here is the e-certificate. Later I will email this to you.
Sure.
So with that, before we officially call it, how about we all take a group photo? My co-organizing chairperson, Lim Jiawei, will take the group photo. So if possible, can I
I
won't guarantee
I
everyone. So
can't.
oh, you
I
can't,
can't.
huh?
You have to Photoshop me later on.
Ah, okay.
I'll send you my profile. You just find a photo of me on Google. Yeah, I can't because I'm using another machine.
Oh, I see, I see.
Yeah. So
So,
okay. So here's the story. I got a Mac and then I was trying to log on using the Mac, so I can't. Right. So, because you didn't add me, you probably don't have the rights to add me as a guest also lah. Yeah. Then I switched to a Windows machine lor.
oh, okay, okay.
Your hair all handsome lah. Don't need to comb lah. Engineering students, ayo.
So, never mind lah. We'll just take a very quick one to show them that we actually did it lah. So, Jiawei, you there? Hmm. Mm, never mind. I'll just take one for Aksa. So
Jia Wei is there what?
yeah, but because he did tell me he was uh busy with something else. So I guess it's fine lah. I'll just take a group photo with us lah. All right. So just give me a moment. Okay. So I guess with that, then our talk comes to an end. So once again, thank you, Dr. Lau, and thank you everyone for
Thank
coming today.
you.
Yeah, thank you. You guys can leave now. All right. So have a pleasant weekend.
All right. Have a good weekend. Bye.
Bye. Bye, everyone.